school in Georgia. I'm also the executive director for SAILea this year, and I plan on pursuing AI and computer science in college. So I've done some research papers on the ethics, some stuff to do with the fair use of AI, but that is my experience. Let's move on to the next person.
Sure.
Okay, does anyone else want to introduce themselves?
Hi, I'm Hanchi. Studying computer science, machine learning in college. Fun stuff.
Nice.
Anisha and I can quickly introduce ourselves. So hello everyone, I'm Ananya. I'm a sophomore. I have a lot of experience with AI. I've done projects with machine learning and deep learning, and I'm really interested in pursuing this subject and its applications in the future. Anisha and I are actually running an AI club at our school right now, so yeah, that's a fun fact. And we're really excited to be here.
Yes. Yeah, so would anyone else like to introduce themselves before we get started? Okay, if that's the case, I'll move on. So there are a variety of different types of machine learning models, and we'll be covering some of them. And some particular models are decision trees, random forest, linear and logistic regression, k-nearest neighbors, and there are a lot more, but we hope to cover a good amount of them in this class. So starting off with, what is AI? So AI is based on patterns and processing large amounts of data and making predictions from it. Unlike traditional programming, which does things step by step, much like a recipe using ingredients. AI gives computers various ingredients and various outputs and have it build or learn the recipe. So supervised learning and reinforcement learning and unsupervised learning. So in simple terms, supervised learning is the process of using labeled examples to predict unlabeled examples. Unsupervised learning uses unlabeled data and discovers structure or underlying patterns in data. And machine learning is the process of learning to pick actions based on rewards and punishments from previous choices. So there is supervised learning and unsupervised learning, as I mentioned in the previous slide, and here's a nice pictorial way to see it. If you look at supervised learning, they're labeled because you can clearly distinguish between the, sorry, it jumped, but yeah. On the left, it's classification, supervised learning, and you can see that it's easy to distinguish between them because they're labeled, and in the case of unsupervised learning, it's unlabeled. So here we have two key concepts, regression and classification. So regression helps predict continuous values, while classification simply classifies or predicts discrete class labels. So in the plot to the left, we have a particular example where we have green dots and blue dots representing some sort of value, and you're trying to classify whether it's green or blue. And on the plot to the right, we have a regression plot where it's just continuous data. There isn't any distinction between them. So below is a practice question on how to classify between regression and classification. So if I wanted to predict the temperature tomorrow in San Francisco, would this be a classification or regression problem? Does anyone want to type in the chat or talk? Yes. Someone wrote in the chat, and yes, it is regression. And the reason why it's regression is that temperature is a continuous. Yes, and you're right. So basically, the sunny or rainy is classification because you have two different classes, sunny or rainy. And in the case of temperature, it's a continuous thing. So good job. Okay, so data is really important when it comes to machine learning and sort of making sense of your data. And we generally split our data into three different sets. Training data, which is used to fit the model. Validation data, which is used to evaluate the model performance at each step, which is specifically called an epoch of training. And um, an example of this is that if I'm designing a model, I would use a validation data set to decide hyperparameters for the model. For example, like how many layers should be included. And the testing data is used after training has completed to observe how well the model does. So it's apart from the training data, and it's just a separate chunk of data that's used to see how well the model performs. Here is an example data set for machine learning. We see that we have like different features in this case for breast cancer, where you have like mean radius, mean texture, mean perimeter, and so on and so forth, and you have different rows. And a way to visualize this is that each row can be thought of as a point in like n-dimensional space, where n is the number of features, um, and the features in this case are the different types of columns. So after training our model, how do we know how well it's performed? So there's a metric that we use for this, which is called accuracy, and it's much like what you would think it would be. It's just a number of correct decisions over total decisions. And this sort of helps us see how well the model actually performed. Does anyone have any questions so far?
Yep, everything is
Okay, looks good. Okay, so Ananya will take it from here.
Yeah, so how can, in addition to accuracy and the metrics that we use to see how well our model performs, how can we visualize the performance of the algorithm? So a way we can do this is using confusion matrices, and be aware that these are specific to classification purposes. Specifically, in this example shown here, it's binary classification. And confusion matrices basically just summarize the performance of a classification algorithm. So if you look at the matrix shown over here, you can see that you have predicted values and actual values. And the predicted values are either 1 or 0. So the model is predicting either 1 or 0. And then the actual values are also 1 or 0. So if you look at the section that's marked TP, those are the values where the model classified as 1 and the actual value is also 1. If we were to move down and look at Tn, this is where the predicted values are negative and the actual values are also negative. So basically, Tp and Tn are the numbers we want to maximize, and they stand for true positive and true negative. We want the number of false positives, which are the number of negatives that were incorrectly classified as positive, and the number of false negatives, which are actual positives but classified as negative. We want to minimize both of those values such that our model will perform well. Yeah, and this is just a quick question for you guys. So in the case where I'm doing something or I'm writing a model to do cancer classification, and one is the case of a malignant tumor, would a false positive or a false negative be worse? Feel free to write it in chat. Okay, so I'm seeing false positive and false negative. Um, yeah, so I understand why like you would think that false negatives would be worse, but in the case where one is malignant, false positives are actually worse because it's predicting something that's benign as, or sorry, false negatives are actually worse because it's predicting something that is malignant as benign. And that, though both are bad, that's much worse. So yeah, good thinking. Anisha, could you move to the next slide? Okay, yeah, so now we'll move on to another general important machine learning concept, which is of underfitting or overfitting for the model. So if you look at the plot shown here, you can see that the data points seem to form this shape around the line in underfitting. It looks like the line isn't really grasping all of the patterns and everything that we need in the data. It's just drawing a straight line through instead of something that should be more like that. In the balance case, we see that the model is perfectly fitting the data and it looks good. But however, in the overfitting, we see that the model does not perform well. It's being way too specific to each and every single feature, which is something we don't want. Let me erase that really quick. Okay, so how can we determine now if we have a trained model and we visualize the performance with a confusion matrix? How can we see how much each feature contributes to the overall prediction? Permutation feature importance is one method to do this that is very interesting. So the way permutation feature importance works is that you will shuffle one of the features and see how it affects the prediction. So for example, if you have features from 1 to 5 and you shuffle them, let's say that feature 2 causes the accuracy to change the most, then that would be the most important feature as ranked by permutation importance. Any questions there? Because that could be a little bit of a confusing concept at first.
Someone asked, so by shuffle, do you mean changing the value? In essence, you're basically just permuting the specific values in a column and seeing how that particular feature plays in the role of like how it predicts. So if you were to have a specific column and you were to permute it and it has a big impact, then you know that it's a feature of importance. So you're not really changing the value, it's more like you're just changing the order.
Yeah, exactly. So like to just put an example to that, say you're predicting if an animal is a cat or dog, and then you have a column that is representative of what's something I could use, um, the color of the animal or something. So if I was to shuffle all of the elements in that column, but keep the rest of the samples the same, how much is the accuracy of the model being affected? The more it's affected, the more important the feature would be. So yeah, good question. Um, Okay, so now we're going to be getting into the main topic for today, which is the decision tree. So a decision tree is a supervised learning algorithm. And as we previously mentioned, a supervised learning algorithm is something that uses labeled examples. So its decision trees can be used for both classification and regression tasks. But primarily, like in the example that we'll be doing later, we'll be using it for classification. And the way a decision tree works is it has a tree-like structure as shown in this picture, which consists of a root node, which is shown in dark blue on the top, branches, internal nodes, and leaf nodes. So basically what the model does is at each step it has a condition called the splitting function, and based on that it will split the data to go either to the left or to the right until finally coming to an output, which would be either 0 or 1 or labeled to particular output. Yeah, and we wanted to start with decision trees because they are the most intuitive to understand, and especially to like someone who's new to machine learning. So feel free to like ask any questions if you have any though. Okay, so how exactly do decision trees work? So I was just saying that decision trees have a condition, and based on the condition, they decide to split some of their data to the left and to the right, and then it just moves down the layers of the decision tree. So how does a decision tree decide what the condition should be at each node? A commonly used method to do this is via the Gini calculation. And what this does is it measures the impurity in a distribution. So for now, ignore the formula. I'll try to give an example to clarify this. So say you have like a bin of 10 balls, some of them are red and some of them are blue. And that is what is being fed into a certain node. Then say, based on your splitting condition, some of them move to the left and some of them move to the right. So say that you have five reds and 5 blues overall in your bin, and you end up having 5 of the reds go to one side and 5 of the blues go to one side. That would be a perfect split because you're at that node, you're perfectly splitting the reds and the blues, which is the ideal case of having a perfectly pure distribution. However, a lot of times that isn't the case. So if you have something like 5R and 5B, you're going to have a mix on both sides of the node. So now that you guys have the intuition for that, like how exactly does the Gini calculation reflect on this? So the Gini is 1 minus the sum of the probabilities squared of an object being classified to a particular class. So we'll actually be going into this further in our Colab notebook where we'll explain this more. But what this basically says is that Gini should be minimized because that's when the purity would be the highest, when the probability of an object being classified to a particular class is the purest. Okay, so how about we walk through an example of Gini calculation? So if you look over here, hopefully you guys can read the text. So in the second layer, the Gini value for the blue box on the left is 0.052. It's specified as Gini equals 0.052 in the box. And this is because it's 1 minus 6 over 225 squared minus 219 over 225 squared. And where did these values come from? If you look at samples inside the blue box, there's a number 225. And if you look at value, you have 6 and 219, where 6 of them belong to one class and 219 belong to the other class. So the Gini value would be 1 minus the probability of it being assigned to the first class minus the 219 over 225 squared. And overall, would you guys think that this is a pure distribution or not if we have 6 and 219 of our two classes?
Feel free to either say it out loud or type it in the chat.
Okay, yeah, good job. I see you guys have all said like mostly pure. That's good thinking. So yeah, that's because we have 6 out of 225, which is like a really small value. So it seems to be that we have majority of our second class. We have 219 out of 225. So hopefully that Gini calculation, that example made sense. Something interesting to note here is actually if you look at the orange box, the values are 141 and 15, which is actually also really pure, but it's not as pure as the splitting on the blue box to the left. Okay, so do you guys have any questions about the Gini calculation or anything before we segue into something different? I think we actually had one more slide that we forgot to present. The screen share stopped. So, okay. So how do decision trees make use of the Gini index? So I explained how Gini index is responsible for representing the purity in the distribution. So first, the decision tree will choose a split function. So if we were to go back to the previous slide, Anisha, could you move to the previous slide?
1 second, sorry, my screen share keeps on freezing.
Yeah, so the splitting function would be worst parameter is less than or equal to 104.95. That seems really arbitrary right now, but that's actually from the COLA that we'll be going into later, which is for breast cancer classification. So that's a splitting function. If we're to go back to the next slide. So based on the split function, the model will find the probability of going to the left node or going to the right node. So how many of them satisfy that condition, how many don't? Then you can compute the Gini for the left node and Gini for the right node. And the decision tree will try to split the split function that will minimize the probability of going to the left times the Gini index calculated at the left node plus the probability of going to the right times the Gini index of the right node. So this is how the model fine-tunes the splitting functions in order to minimize the Gini index and yeah, hopefully that made sense. That's a great question. So how does it create a split function? So basically, as our model trains, it's going to see the accuracy that's produced and keep modifying the split functions for the number of nodes. So actually, while creating your decision tree, you can specify the number of the depth of your model. So how many different layers of nodes do you want to have? And based on that, the model will try to determine the split functions that will maximize the accuracy. One thing with decision trees, though, that is important to be aware of is that it's possible for them to overfit quite commonly because just because of the structure and also because if you don't specify the depth or you include a very large depth, the model can literally just mold to the training data and not perform very well on the test data.
Yeah, and there's actually going to be a question on that in the Kahoot, but it's a good point to note. Okay, so if there aren't any questions, we'll be moving on to the Kahoot. Give me a second.
Yeah, so the game pin's over here. Feel free to join the Kahoot right now. We'll wait for you guys to join. Manisha, I think you're on mute.
Oh, my bad. Is there anyone else needs to join? Or is that it? I think that's it, but last call if you're not in. But... Okay, we'll start. Okay, so a couple people put all of the above. The correct answer is label. As we mentioned in the slide, um, you would need to use labeled data for this sort of learning. Does anyone have any questions? Okay, we'll move on.
Yeah, using unlabeled examples or samples, that falls into the category of unsupervised learning.
Yes, good job to those who got it correct. This was actually, well, kind of related to what we were talking about, but good job. Everyone got it right. So I'll move on. And once again, just to recap, regression is for continuous data. So in the case of temperature, it's the only one that would fall into that. So yeah, let's move on.
Okay, I can just briefly explain this. So, an epoch is a term that's used for one round of training. So what exactly does it mean by one round of training? So basically that means that it just goes through the entire data once, and then you can repeat this multiple times, and you normally can indicate this by a for loop, how many times you're going to go through the data. And the number of times is represented by the term epoch. Yeah. Good job, guys.
Good job on having the highest answer streak of 3. Okay, so here we have a confusion matrix where we have a certain example with true negatives, false negatives, and true positives of different values. And can you explain how well the model performed? Like how many samples were predicted correctly, how many were predicted incorrectly? Does someone want to give it a shot?
MA or Emmy, sorry. Do you want to explain how we could go about this?
So you just compare the predicted values to the actual values. So it got 10 false positives and 5 false negatives. So it got 15 wrong total, I think.
Yep, great. So would you say that the model performed pretty well with like a high accuracy or not so much?
I would say so because it got like a high percentage of true positives and true negatives.
Great thinking. Yeah, exactly.
Yeah, great. And if you were to just say like how many samples were predicted incorrectly, it would just be 10 plus 5, 15. And these ones are the ones predicted correctly, which is 150. Yeah, great job. Okay. Next question. We kind of covered this question, but just quick recap. Yeah, that was a pretty easy one. Everyone got it correct. It does exhibit underfitting because the line doesn't really make good sense of what the data points actually are doing. Great.
Any questions so far? Feel free to like put it in chat.
Good job.
Okay, great.
Everyone got it. Oh, sorry. Yeah, you
I'm
can.
not exactly sure how to pronounce the name, but it says INSC, I think. Would you like to unmute yourself and explain why you picked the answer that you did? Okay. Do you want to put it in chat instead then?
Yeah, that's basically it. So you said that it memorized the training, so it did well in the training. Yeah, so that's exactly. So basically it conformed to sort of what the training data was like. Um, yeah, basically exactly what you're saying. Nice job. Does everyone
Yeah, how might not
understand?
generalize because the model would just be really specific to just the training data.
Exactly. Does that make sense to everyone? Good job, Emmy. Okay. So we did briefly go over this, but what is permutation importance? So could someone define either in the chat or by unmuting what permutation importance is and its specific use when it comes to testing out models?
We'll give you guys a couple minutes to think through this and think back to what we were talking about. Okay, either Emmy or I'm sorry, I don't know how to say your name, but one of you guys, would you like to unmute and explain your thinking or put it in chat?
Are you guys unsure on what it is, or feel free to type in the chat if you can't unmute. Yes, exactly. So you're basically going to be permuting a column to analyze Well, okay, so it's not exactly what you said because you're saying it's switching around the columns. It's actually just you're switching around specific entries in one column and seeing how that specific column affects the accuracy. So it's kind of a subtle difference, but you're saying that it's switching around columns to analyze which column has the most effect. Um, it is, yeah, as some other people wrote in the chat. Yeah, no problem. But good job to everyone who wrote in the chat. Does that make sense to everyone? Okay, we'll move on.
Okay, so we'll now get into the decision tree review and discuss the Gini index once again. So hopefully you guys will get a better grasp for the concept.
Quick thing about this question, ignore the picture. The picture is just, it's irrelevant to the actual problem. So ignore like the colors and stuff.
Yeah, the picture's just there, I think, to like, we put it to just give you guys an idea of what purity is. So.
Okay, so mostly everyone got it right. And the answer is blue because it is almost an even split out of the options that we have. It's the one that has almost the most even split. Does that make sense to everyone? The reason why it's like not yellow.
Yeah, so like if you look at red, 5R 6B and 6R 5B, that's like extremely close on both sides. It seems to be around 50% red. If you look at the yellow option, it's a little bit better because instead of 5 and 6, you have 4 and 7, a slightly higher percentage of one compared to the other. But this is still not very pure compared to the blue option where you have 10 of one color, 1 of the other. So hopefully that makes sense to everyone. Let me know if you want to go back to the slides and we can discuss that again.
Just like put a thumbs up or type in the chat that you're good to go on. Since no one's really reacting, I'm not sure if you guys are fine with moving on. But yeah, I guess I'll just move on. Okay.
I think someone was kicked out of the.
Hey, if you guys want, I can explain this one. So I'm not part of the Kahoot, but you'd usually want to minimize the Gini index because it lowers the likelihood of misclassification.
Exactly. Good job, because everyone did get that right. And if you were to see that like pictorial like parabola, it's basically the I can't really go back to it, but it's basically the like endpoints is what you want it to be, because that's when it's the most even split, and when it's like the vertex is when it's like the worst, because that means that like it doesn't know what it's doing. It's a 50% probability that it goes either way.
Exactly, yeah.
Okay, great. Let's move on. Hint, it's obviously a quadratic because we graphed it in the previous slide, so that kind of narrows down the options. Correct. That is correct. So, great job, everyone. Great job, everyone. Hopefully you guys got something out of this Kahoot, and hopefully it was a good review for you guys.
We'll just take a quick moment. If any of you guys have any questions or you think of anything, feel free to ask us right now before we get into something different, or we recap this.
Glad you guys enjoyed the Kahoot.
I just want to show you guys this really cool visual implementation of how a decision tree looks. It kind of helps with understanding how it works, I would think. So yeah, so this is from a site about a visual introduction to machine learning. I just scrolled down to the part about decision trees. So as you can see here, the training accuracy is said to be 100%. And then if you scroll down, you can see how the data would flow through in the case of testing accuracy. So here, I believe that the empty, like not filled in circles represent unfamiliar data to the model. So if you go like this, you can see how complicated decision trees can get, especially if you increase the number of layers. And this makes it easier and easier to overfit as well. So yeah, and if you look at the test accuracy number here, it's only around 85.5%. And if you finish it up, it doesn't get anywhere near 100%, showing that it is possible for decision trees to overfit. I can share this link with you guys if you would want to read through the rest of it. It's a really interesting read about decision trees and in general visualizing machine learning.
Yep, that'd be great if you could share the link with us.
I'll put the link in chat. Okay, so we'll get into, we don't have too much time for this right now, but we can start to look at our coding notebook about how to implement decision trees. For the first notebook, we decided to make it a lot more, like we're showing you guys what to do, so you guys can get familiar with the rough outline of how to implement machine learning model. But in the future, we're going to be having interactive, like you guys have to type in the code and see how it works. So I'll share the notebook with you guys so you can follow along, but I will also be presenting my screen. For some reason, my screen share is loading. I'll try it again in 1 second. Okay. So So we explained how decision trees roughly work, the theory behind them, their structure, and all of that. So the purpose of going through this collab is to just give you guys a first exposure to how it's implemented. So important packages for implementing machine learning is mostly just sklearn. This contains the decision tree module as well as different machine learning models that you can implement, different models that we'll be getting into further on in the course. We also import matplotlib, seaborn, and numpy. Matplotlib and seaborn are particularly useful for data visualization and graphing different things that you want to see. So the first thing we start by doing is we start by loading the breast cancer data set. This is note that this is actually a data set that's already built into sklearn, so we don't have to like read the file as a CSV and do all of that. And we just chose this file because it would be easy to understand for the first time.
Yeah, and to sort of get an idea of like how the data set looks and things like that, there is an attribute called DESCR, which basically describes the data set, the features, the different columns. So if Ananya were to scroll down, so it kind of gives a brief summary on the different attributes or columns in the data set, such as radius, texture, perimeter, area, and so on and so forth. Could you keep scrolling down? And it sort of just like summarizes the min and max values for each. It just gives you like an overview of how the data set's like. And then to actually see the data set, you can do .head. And this allows you to see the first 5 rows of the data set. And this is actually the screenshot that we had in the slideshow where we have basically a chunk of our data set with all these column names. And if you were to scroll all the way down, we have a column called target, which basically says whether it's cancerous or not. So that's basically the target. And that column is super crucial for like any model to work with because that basically is telling you whether it's benign or malignant. So
Yeah, and note here that mean radius, texture, perimeter, all of that are different features that our model is going to be using to predict if a specific sample would be malignant or cancerous for breast cancer. Or sorry, did I say malignant or cancerous? Malignant or benign? Yeah, so there's actually a really interesting paper outlining this data set and everything.
yeah, I
So,
think the link is at the top. But yeah,
yeah,
sorry.
the link is at the top of the notebook. I can put it in the chat. I'll do that right after I explain this. But this picture shows a sample tumor scan, and from this picture, the various features that I talked about above, such as concavity, area, perimeter, radius, all of that, they're all reported. So I'll just put the link if you guys want to understand more about how this data was collected or like what exactly the model is training on. Also, I just wanted to ask you guys, have you guys had any experience with using sklearn before, or have you heard of the package? You can put a yes or a no in the chat.
Great. See some responses in the chat. No worries if you haven't really used it yet, because we'll be walking through a lot of examples, and you guys will be able to code it on your own too, to sort of get an idea.
Yeah, it's perfectly fine if you haven't heard of it. So we'll be starting with doing some data visualization. So before training and testing our model, we can take a closer look at how these features are represented. So we decided to pick the mean area feature, which was above in our data set, and the target column. So what we do is we use SNS, which is the seaborn package, and as I said earlier, it's really good for data visualization. And we're plotting the mean area and the target, and we're going to see if there's some sort of a correlation between them. So you can see that mean areas that seem to be smaller, like between 0, 500, maybe 1,000 even, are related to the target being 1. But for values greater than that, it's 0. But notice that there's this area in between. Let me see if I can annotate. This area in between that's kind of amorphous, it's a little hard to classify, as well as this region here because it seems to overlap with the area below. So that suggests that this feature might not be the best one to use or the most reliable one for our model. Yeah, so like how would you want the plot to be if it's an important feature?
Give you a couple seconds to think about it.
It's always really important to start with data visualization before you get into the model, so you can really understand like what is the data that you're using, how is it structured, what features would be the most important, that sort of thing.
Exactly. That's exactly what you'd want to see. You would want to see sort of a clear distinction between 0 and the 1s. And actually later in this collab, we'll be plotting, once we know like through feature importance which ones are the best features, we'll actually be plotting them to see the clear split later. So nice job.
Okay, so in this specific example, as I mentioned, we see that mean areas less than 700 approximately correspond to malignant cases, while there doesn't seem to be a clear relationship for benign cases. It's all over the place, not clustered really in one area. It spans the entire spectrum. So this suggests that this feature may not be the most important for our model prediction. Do you guys want to see what would happen if we try a different feature? We can maybe try mean concavity.
Yeah, and feel free to play around with it on your own too and sort of test different features and see how it
Oh,
looks.
I would have to run everything. Yeah, so the great thing about collab notebooks, if you guys aren't familiar with them, is that you guys can actually experiment with them on your own, run the code, and ask us if you have any questions. Okay, so what do you guys think about this specific feature? Is it better or worse?
Yeah, I'm sorry about the static. Like, there's kind of an issue with our laptops, and it kind of sounds like birds chirping all the time. I'm sorry about that, but yeah. Yeah, okay. So yeah, there does seem to be a lot of overlap, and it honestly seems to not be like it seems to be worse than the other feature because there are a lot of like outliers. Um, and feel free to try some on your own to sort of get an idea of which ones seem better to you, and later we'll see if those indeed are better or worse. Okay, so before we can sort of get into the machine learning, we have to split our data into training set and testing set. So here in this particular like split that we're doing, we're allotting 1/3 of our data to be used for testing. As we can see that it says like test size is equal to 0.33, which is approximately 1/3. This was just, it doesn't have to be 1/3. This is just what we decided to do. You could have done like 1/4 or something, but yeah. And as you can see, like X, which is going to be like everything but target, and Y is going to just be target. And you're splitting from that.
Just like a quick thing to throw out there. Do you guys think having 1/3 to be used for testing is enough? Or like how do you guys think we should how do you guys think the data should be split generally?
if you're not sure, there really isn't a clear answer to this question. It sort of just depends on what you sort of want to do. So mhm.
Yeah, that's a really good point about validation. So in this specific example, we don't have validation because validation set is something that comes more into play when you're doing deep learning or with a more complicated model and more data. But it's a great point to make. And a
Yeah.
lot of times it comes with experimentation, like would 1/3 be the best, 1/4, yeah. And Emma, what you were saying, too small would mean inaccuracy and too big would make the training results inaccurate. I think, yeah, that makes sense.
Good thinking, everyone. We will actually be getting into the machine learning part next week, so that's basically it for today. If you guys don't have any questions.
Yeah, and if any questions pop up, you can contact us at our emails. I'll put it in the chat. I'll be sending the link to the collab next meeting after we walk through the rest of it because I want that to be like interactive and we get to experiment with it. So yeah.
Awesome. So before we move on, I want to say thank you to both Ananya and Anisha for today's meeting. And thank you to everyone else who joined with us today. And real quick, if you aren't a member of SAILea yet, make sure to join our organization. You can find our sign-up form at sailea.org. And we will be trying our best to do these meetings every 2 weeks. And so when you join, you'll have access to all these presentations, collab notebooks, and any other interactive resources that we put out. But yeah, once again, thank you both of you for such an awesome presentation and an interactive session today.
Yeah, it was great teaching it. Hope you guys enjoyed, and feel free to email us if you have any questions.